Today in class, we're going to look at the derivative of a logarithm. And so before we do that, I wanted to take a bit of time to review some of the things you would have learned in 108. In particular, the average rate of change, the instantaneous rate of change, and the definition of a derivative. So let's first of all look at the average rate of change. If we have a function, y equals f of t, then the average rate of change over an interval from a to b then is just the change in y over the change in t on that interval. All right, so it's delta y over delta t, which is essentially rise over run. All right, so this is a slope. This is a slope calculation, but this function may be nonlinear. It may not be a line. So it's the slope of a line segment connecting those 2 points. All right, so let's take a look at example 1. We're given the function in tabular form. And the first thing we are asked to do is sketch a graph of this function and then determine the average rate of change over the given intervals. All right, so to sketch a graph, we're just going to plot these points. So we have x, y pairs, right? So when x is 0, y is 2. All right, now my scale is, I have to find out where 2 is. It's somewhere around there. Let's say it's about a fifth of the way up to 10. And then when x is 2, y is 8. So we'll put a dot about there. And then when x is 4, y is 18. When x is 6, y is 32. And then when x is 8, y is 50. All right. So we can plot those points, and then assuming that this function is continuous, we can connect it with a curve, right? So I'm just going to try to draw a curve connecting those points. Oops. Try to draw it as best I can. All right. So my lines aren't very straight, but so you can see it's got a little bit of a curve to it. It's not a line. It's got a little bit of a curve to it. So let's go ahead and calculate the average rates of change over these intervals. So the first interval is from 4 to 8. All right, so 4 to 8. So we're going to do f at 8, which is 50, minus f at 4, which is 18, and then we're going to divide by 8 minus 4. So when I do that, I get 8. All right, I'm just going to do the same thing for each of these intervals. So from t equals 4 to t equals 6. Let's see that f of 6 is 32, f of 4 is 18, and then we're going to divide by 6 minus 4. And when I do that calculation, I get 7. All right, now we're looking at the interval from 2 to 4. All right, so I'm going to f of 4 is 18, f of 2 is 8, and then I'm going to divide by 4 minus 2. So I get 5. And then the next interval is from 0 to 4. All right, so f of 4 is 18, f of 0 is 2, and then we're going to divide by 4 minus 0. So I get 4. All right, so those are our average rates of change over the intervals we're asked for. And then it says on the graph, show the average rate of change for each interval as the slope of a line segment between 2 points. All right, so these average rates of change are the slope of line segments. And so I'm going to try to draw some line segments here. I'm trying to use the line tool because sometimes I can't draw straight lines very well. The first one is just from 4 to 8. So I'm going to try and draw a line from 4 to 8 like that. All right. So there's a line segment. I don't know if I can change the color. Let's see. Can I change the color of it? I'm not sure. But you can see that that would be the line segment between 4 and 8. So I can let's click off that. And now I'm going to draw a line segment between 4 and 6. Okay, so in a similar way, I'll get a line segment like that. The slope of that line would be this, the slope between those 2 points. So the slope of that line is 7. All right, so let's keep going. Let's draw a line segment between 2 and 4. Okay, so 2 to 4, is that a line segment? Wish I could make these a different color. don't know if I can make them a different color. Pen properties. Could change it to red or something. Okay, maybe red's better. And then let's draw another line from 0 to 4. All right, so the last interval is from 0 to 4, so we're just going to draw a line here from 0 to 4. And I guess I'll make that one red as well. Okay. All right, that looks a little better. I'm going to make these red as well. Let's see. Okay. Taking all this time. Changing the color just so that it looks different from the actual curve, which is my green sketch there. All right, so those are the line segments. All right, so what's the next question? What is your best estimate for the rate of change of this function at t equals 4? All right, so now we're asked for a rate of change, but not over an interval. We're asked for the rate of change at a particular point. All right, so you can imagine that we could take intervals that are closer and closer together around 4, and if we took a line segment between say 3.75 to 4.25 or something like that, we would get something that's closer to the average rate of change at 4. Okay, so and we could even go closer than that. We could do 3.9 and 4.1, or we could do 3.99 and 4.01, and we could get a value. So, but you can estimate what the average rate of change is from what we've got, just because we know it looks like the slope of this curve is getting steeper, right? And so on one side, on this side, from 2 to 4, we have the slope is 5. From 4 to 6, we have a 7. And so it would seem reasonable that the slope at 4 would be somewhere between 5 and 7. So I'm just going to write. So like I said, the rate of change is somewhere between 5 and 7. And if we average those two values, we get 6. So a reasonable estimate for the average rate of change at 4 is about 6. All right, so I will meet you in the next video for the next example.